Okay, at this point in the presentation, we're going to take a slight side step and talk about something called mutability. Mutations, the ability to change, and you may have come across mutability in Python. Some things are mutable and some things are not mutable. So we're just going to talk about things that are not mutable to start with and try and get our mind around them. Now, it's quite a weird concept in Python, this. And we're not suggesting that you kind of delve in and start teaching this straight away to kids, or this is not how we would normally start in Python explaining variables. You can understand a lot of how things work without worrying about this detail. But as you progress in Python, you will need to get your mind around mutability. So the jury's out about exactly when we should teach it and when not. Certainly kind of not early key stage 3. Stuff like that. It is quite an advanced concept in some ways, but for you as people trying to really get your mind into how Python works, you do need to understand this. So that's why we're going to cover it. So let's explain mutability. So depending on where you've learned Python, if you've been on one of my courses, I'll have told you about jam jars. And in fact, probably the first time you learn Python, or if you've read a book or you've been on websites, we've talked about jam jars. And we use the jam jar analogy to explain variables. We talk about jam jars for storing integers, strings and floats. And they are what are called non-mutable. And we're going to explain this term non-mutable. And we're going to justify as we go through the program why you need to understand this concept. So let's just delve straight in. We teach when we issue the command age is assigned the value 10 with the age equals 10 command, that creates a jam jar and we put the value 10 in it, and we label the jam jar with the label age, and that's basically what a variable is. A variable is a jam jar with a label. We like the jam jar analogy because the number's in there and it means we can take it out of the jar and change it, and we can put other things back into the jam jar. So what we teach is, if we did these sets of commands, age is assigned 10, the age goes in the jam jar. We then teach that if we did the command age is assigned age plus 1, well, what do we actually teach? We teach that 10 is pulled out the jam jar. We teach that we add 1 to it, which obviously creates as the value 11, and we teach that 11 now goes back into the jam jar. So age has now changed to 11. And for 99% of the time, that's a very good explanation and will work, and nobody will care that it's not actually true, because it's a good enough teaching explanation and it will work for most of what we do. The reality is it's not actually true. And just one very easy way to justify why it's not true is think what would happen if we didn't increase age by 1 but maybe increase the value of age by 1,000. Think what would happen then. Well, what you first need to think about is what happened when we did the command age is assigned 10. Now obviously in the computer it actually had to find memory to store this number 10 in. The number 10 can easily be represented in 1 byte in 8 bits. So the memory, the computer, allocated a byte to store this number in. So it's now reserved 1 byte in memory. If we now added 1,000 to that, age now would be 1,010. And if we had a jam jar of the same size, only 1 byte, we couldn't store 1,010 in there. So we'd have to grow the jam jar. In fact, if you think about it, we'd need 2 bytes to store the number 1,010. Well, you can't just go and nick an extra byte in memory. Maybe that byte's been allocated for something else. So the fact that jam jars are created to a specific size means that anytime we change the contents of that variable, we can't use the same jam jar because it might be bigger or indeed smaller than the original one. So the reality of what actually happens is when we do the command age equals age plus 1, it takes the value 10 out of the jam jar. It adds 1 to it to get our value of 11, and even though in this particular case it would fit back into the same jam jar, the general rule is get yourself another jam jar, and the value 11 goes into there. And what do we do with the label age? Well, we just point it to the new jam jar. And that's what we call non-mutable. It means that we can't change what the value of age. Age had the value 10. We cannot change the value 10. 10 is there in memory. I cannot make it bigger or smaller. All I can do is create a new jam jar, a new location in memory, put the value in there and just make age point somewhere else. The more astute amongst you might go, hang on a minute, what happens to that 10 floating in that jam jar with no label? Well, there is a process inside a computer that basically cleans up unused jam jars. It's what's called unreferenced memory, and it's done through something called garbage collection, which is a process that happens in the background. Rest assured, it doesn't get wasted or blocked endlessly. So, from a point of view of teaching the basics of programming, the fact that a new jam jar has been created is neither here nor there. So we wouldn't need to worry about it on the whole. But we need to worry about it when we start passing parameters around. Okay, just to show you what that means in action, let's just have a quick look at the Python code itself. We've got some code here which is age is assigned the value 10. We're going to then print age, and we're going to print something called the ID of age, which is the identifier, which is essentially where it's stored in memory. We're then going to increase the value of age by 1 and reassign it back to the same variable age, and we're going to print age again, and we're going to print the ID of it. So we just run that little bit of code and see what happens. So here you go, we've got the value 10 printed, then we increase the value and it printed 11. But you'll notice that when we printed the value 10, it was stored in this memory location ending 712, and once we'd increased the value, it was in a different memory location, 728. So it's not the same jam jar effectively. That was the whole point of that little exercise. It shows that it has actually created a new variable called age and just moved the label. It's now a different memory location. Okay, so the code is actually there in the presentation, and this function ID is quite useful. We use it in other parts of programming just to identify when things are pointing to the same location. We'll explain more of that later. So let's have a look at another thing just to kind of get your mind around to do with this non-mutability of integers, strings and floats. Looking at this little bit of code here, we've got name. Obviously a variable is assigned the string Izzy. I've obviously got smart quotes that have been picked up there, so they should just be standard quotes. What does that do? Well, obviously it creates a jam jar, puts the string Izzy inside it, and creates a label called name pointing at that particular jam jar. Pretty straightforward. We then set new name equals name. So we've created a new variable called new name, and we've assigned it the same value that the variable name has got. And we can see the variable name is storing the string Izzy. So what actually happens here is quite interesting. What happens here, I'm sorry, I don't know what's happened to my jam jars there. What happens here is when we create this new variable, rather than creating a second copy of the string, which would be rather wasteful in memory, when we create this new variable, new name, it just points to the same instance of that string. So it still points to that Izzy. So we haven't duplicated the amount of memory. Both variables, they seem to be independent variables, but at this moment in time, they both have the same value in there, so they're both pointing to the same memory location, and that's storing the string Izzy. So what happens now when we say new name equals Rudolph and we change the variable? Well, hopefully you should know the answer. Strings are immutable, we can't change them. So there's no concept of changing the value in that jam jar. If you think about it, it wouldn't work. The jam jar is only big enough to store 4 letters, and now we're trying to put Rudolph in there, so it wouldn't fit anyway. So just like happens normally, if we change the contents of a variable, we don't actually change what's in the jam jar, we create a new jam jar. So what will happen now, we'll get a new jam jar, we'll put Rudolph in there, and new name will point to the new jam jar. So again, we couldn't change the actual variable. Izzy was fixed, and obviously in this case it wouldn't have made sense to do so because name was pointing there. Once we change a new name, we just create a new jam jar, i.e. create the new variable, and make the variable name point to that new location. And that's how it actually works in reality. Okay, I hope that made sense. So, just to summarize, ints, strings and floats are immutable. We can't change them. For 9 times out of 10 you don't need to worry about this. We'll be looking at strings in a bit, and there you will, but 9 times out of 10 you don't have to worry about it. The jam jar and changing the contents will work, and it should be easy for people to understand, and it will work in a lot of programs. But later on you do need to get your mind around this concept. Okay, so that's that section. What we're going to go on to do in the next section is we're going to look at the implications of how these jam jars and labels work for when we pass information in and out of functions